Hello Year 12, here are the answers to your 5 a day. Let me know if you have any questions about those. So today we are going to be looking at applications of functions. This is our final section of our functions and relations chapter. We're going to be looking at how we model situations with functions and then use this model to solve problems. So we're going to start with an investigation. I want you can either actually do this or you can just think about doing this. Taking a square of paper that measures 20 centimetres by 20 centimetres. Now if you cut out squares from each of the corners, you'd be able to fold up the sides to make an open-topped box that looks a bit like this. What I want you to consider is how big would you need to make your squares to give you the largest volume of box. So pause the video while you have a think about this. Then when you think you've got to an answer, or if you need a bit more help to get to the answer, then press play again. So whenever you have something that's going to be changing, the best thing to do is give it a name. And so in this case, I'm going to call the length of the sides of the squares x. We're going to introduce a variable. Now, consider what the length of the sides of this red square would be. Remember, we started with the whole edge was 20 centimetres. Well, we cut away x here, we cut away x here, and it's a square. So each of these red sides would be 20 minus 2x. Now, find an expression for Vx, the volume of the box. Hopefully you remember that the volume of a cuboid or rectangular prism is length times width times height. The length and the width are both 20 minus 2x. The height is going to be x. Now, we need to consider the domain of this function. If x was 0, I wouldn't have a box. It would just be a flat piece of paper. So our x has to be greater than 0. Now, if my x were to get bigger and bigger and bigger and bigger, there would be a point where the cuts would meet each other. That's halfway across when we have 10. And if I cut out a 10 by 10 square from each corner, I wouldn't have any paper left. So my x must be less than 10. So here's my domain. Of course, we could also write this like so. Now, if we consider the graph of the volume function, it looks like this. Now, I haven't restricted my domain in this diagram, but we're going to ignore this bit and ignore this bit. So for any value of x, this gives me my volume. We can clearly see that my maximum volume is here at the local maximum of the graph. Now, on your CAS, you can get your CAS to tell you what the maximum point is. And I will have a look at that in a moment. But let's just see for this one here. This occurs at the point 10 over 3 for x and this lovely value here for the volume. I'm asked what the maximum volume is, so I need to find that x is equal to 10 over 3. But then I need to give the actual volume, which I've rounded to the nearest integer here. It didn't tell me to do that. I wasn't given a specific degree of accuracy, so I've just chosen to do this. Now, I've put the function into my CAS and I've got this. Now, if we compare it to the diagram I have here, you can see I'm missing some useful information. Now, what I need to do is I need to make my window zoom out. So I go to Menu, Window Zoom. Now, it's always a good idea to start by going to Zoom Fit because the CAS might work for you. This is good enough for me because I've got the part in between 0 and 10, which is all I need. Of course, what you could have done is Menu, Window Zoom, and then you can zoom in and out, or you can go to Window Settings and input your domain and what Y values you want to see. But I'm happy with what it's given me here. Now, if you again go to Menu and then Analyze Graph, we want to know where the maximum is. So if I select that, you'll see there's this dotted line that you can move up and down. Now I'm doing that with my mouse. On your CAS, you need to use the touchpad here to scroll back and forth. Now you need to tell your CAS where to look for the maximum point. It's here, so I need to click somewhere to the left of it to give the lower bound, and then move across to here until it finds the maximum, and then click again. You can see there it's found my maximum and it gives me my value. Because my degree of accuracy that it's set to is just 3 significant figures here, it's rounded for me. You would be able to change that if you wanted. That's good enough for me for now. And if you're not sure how to change it, that can be something we talk about at some other point. Now, for all of the questions, so that's questions 1 to 7 from exercise 1H, you can use your CAS, you can plot graphs on here and so on your CAS. Yeah, you can plot graphs on your CAS. I would have also been able to solve this question using differentiation. If you know how to do that, then you're welcome to use differentiation to solve these problems to do with minimizing and maximizing things. However, just analyzing the graph is acceptable for now. So these are your questions. Make sure you mark your work as you go. And each one's going to be a slightly different situation. So if you get stuck, then just make sure you ask. Apologies for the dog that has started barking in the background. Thank you very much.